Hello and welcome to my video how Samuel Rowbotham accidentally debunked Flat Earth. Who is Samuel Rowbotham, you ask? He is merely the most famous flat earther in history. He purportedly proved that Earth is flat with his infamous Bedford level experiment that actually didn't prove anything because it was badly designed. He wrote several books about Flat Earth and he inspired the founding of several Flat Earth societies, the most recent one being the Flat-Earth Society. Well, actually there are currently two the Flat-Earth Societies because of internal infighting. Please do go check out both their websites. They have, for example, come up with their own non-testable explanations how light and gravity work on a flat Earth. But please be careful when asking questions on their forums. These pseudoscientists are super touchy. Here is the experiment where Rowbotham accidentally debunked Flat Earth. In all fairness, he likely didn't even realize that he did. On noon of July the 13th, 1870, Samuel Rowbotham triangulated the position of the Sun, and he published his results in the third edition of his book, Static Astronomy, Earth on the Globe, in Chapter 5. In London, one observer saw that the Sun is at an angle of 61 degrees up in the sky. At the same time, another observer in Brighton, exactly to the south of London, saw that the Sun is at 64 degrees up in the sky. And knowing that the distance from London to Brighton is 50 miles, Rowbotham calculated that the altitude of the Sun is 700 miles and that it is vertically above the location 400 miles to the south of London. Simple, straightforward. So that's his data. 61 degrees, 64 degrees and 50 miles. In reality, the distance from London to Brighton is more like 46 miles, but we will see in a minute that this error is negligible. What model did Rowbotham use for calculating the coordinates of the Sun? First, he assumed implicitly that the Sun is an object with a definable location. This assumption is valid because it is possible to empirically predict the location of the Sun in the sky. No one is surprised when the Sun rises at the time it was calculated to rise. Nobody is surprised when a solar eclipse happens when and where it was calculated to happen. Second, he assumed implicitly that sunlight goes in straight lines. This assumption is valid because atmospheric refraction is only a problem for angles close to the horizon, when the sunlight moves at a flat angle through layers of varying air density. We are 60 degrees up in the sky. Third, he assumed explicitly that Earth is flat. We shall see about the validity of that assumption in a minute. Just to be sure, let's do our own analysis with his data. We set up a Cartesian coordinate system with the x-axis going south and London at 0, 0 for ease of calculation. In London, an observer saw the Sun up in the sky at an angle of 61 degrees. That defines a line y equals tangents of 61 degrees times x. The Sun is somewhere along this line. In Brighton, 50 miles to the south, an observer saw the Sun up in the sky at an angle of 64 degrees. That defines a line y equals tangents of 64 degrees times, open bracket, x minus 50 miles, close bracket. The Sun is also somewhere along this line. This means the Sun is where these two lines intersect. And they intersect at the location that is 400 miles to the south of London at an altitude of 700 miles. And we see whether it's 46 or 50 miles, we get more or less the same result. So, that means we just proved that on our flat Earth, the Sun is at an altitude of roughly 700 miles. Case closed, let's go home. Except, does our calculation make sense in real life? Let's plot what we just did. So, here we have the line of sight starting in London and the line of sight starting in Brighton. We have the coordinates of London, the coordinates of Brighton and the coordinates of the Sun. And the Sun is vertically above some location. The tricky question is, what is this location? What is at that location in real life? Well, we know that it's 400 miles to the south of London, so it's somewhere in eastern France. What's this fuss all about? You see, the problem is the Sun was vertically above the latitude 46 degrees north. Do you see the problem yet? How about now? The Sun was vertically above this position. Do you now see the problem? The Sun can only be vertically up in the sky for locations south of the latitude 23.5 degrees north. So, Rowbotham's calculation has only two possible conclusions. First possible conclusion, the Sun is vertically above the latitude 46 degrees north. That's utter nonsense. Second possible conclusion, the latitude 23.5 degrees north is in France, which is also utter nonsense. If a conclusion is nonsense, then one of the assumptions must be wrong. Well, the Sun does have an empirically definable location, and at these angles we don't have problems with refraction. By exclusion, that leaves only one assumption that can be wrong. The ground connecting London and Brighton is not a straight line. Earth cannot be flat. If we assume Earth to be flat, we get contradictory statements on where the Sun is, on what the distances between locations on flat Earth are, on which latitude is where on flat Earth. If we assume flat Earth, nothing makes sense. And by the way, have you ever wondered why flat earthers can never agree on how high the Sun is above flat Earth? Wilbur Bolivar calculated an altitude of 3,000 miles. Rowbotham calculated 700 miles. On a flat Earth, the Sun would have to be in several different altitudes at the same time. In summary, using the assumption that Earth is flat, Samuel Rowbotham triangulated a location of the Sun that would put it simultaneously on 46 degree and 23.5 degree latitude, simultaneously vertically above France and vertically above the Sahara Desert. Therefore, the assumption that Earth is flat must be false. And if the famous flat-earther Samuel Rowbotham calculated that Earth cannot possibly be flat, who are we mere mortals to doubt him? Thank you for watching my video, and please also check out these channels. Goodbye.